Hello everyone, welcome to my next video. In this video we're gonna learn about how to generate contour lines from our digital elevation model and prepare a slope map using these contour lines. Okay, for this session you will need to download a digital elevation model. I've already explained about downloading a digital elevation model in my previous video. If you haven't watched my previous video, I have provided the link to that video in my description below. You can directly click on the link and watch that video. Now I hope that you have already downloaded the digital elevation model, and let's set the digital elevation to the ArcMap. After adding DEM, we need to project the DEM according to the location of our work. Currently we are working on Dang district that lies on UTM zone 44N, so we're gonna project it accordingly. After that we can simply remove the unprojected one and keep on working with the projected raster. We can generate contour from our digital elevation model by simply using contour tool that you can search on the search box, and after opening contour, input the DEM and you can define the contour interval. I'm using 5-meter contour interval in this map and click OK. After completing, we can simply close it, and the contour lines are loading. After loading, it looks like it is totally covered in blue color. It is not any kind of error, but simply due to high density of the contour lines. And now you can add the boundary polygon of the study area or the community forest you are working in. When you zoom to the boundary polygon, you can see that the contour lines are clearly visible. Now you can simply follow these steps to make a slope map from contour lines. We have added the contour and boundary polygon, and now we have to clip the contour lines only within the boundary polygon. After completing, you can simply close it from here, and after closing, you can just keep only the contour line within the boundary polygon by unticking this one. And the next step is creatine. You can find creatine tool inside the search box, and after opening creatine, you need to define an output location. And define a projection system and give the input, and in the height field you need to put the column that contains the height and type soft line and leave other thing default and click OK. And finally the tin is created, and after creating you can just close it, and let's make the boundary polygon hollow so that the tin is clearly visible. The next step is tin to raster, and simply type tin to raster in the search box, and you can get the tin to raster tool, and you should give the input tin and define the output location. Remember that for defining an output location, you should add the name, and after the name you need to provide the .tif extension that denotes the raster. Okay, and after completion you can remove the unnecessary files. Okay, and keep only the raster and polygon and contour lines. Next step is slope calculation. It has calculated the slope map, but you can see that the slope categories are defined by default, and we need to reclassify it so that we can define our slope classes according to our choice. Till now the slope map is in raster format, and we need to convert it into the vector format by using raster to polygon tool so that the slope categories are defined by polygons. We input the raster as reclassify.sunpur, and we define the output location. Okay, now it is completed and the polygon is in the vector format. Now the next step is we use the final clip tool so that we only get the slope map inside the boundary polygon. You can see that till now the slope is outside the boundary polygon also, so we need to clip it inside the boundary polygon only. Now we can remove the unnecessary files and only keep the final clip polygon. And now it is in the single feature format. Now we can just go to properties and symbolize the map according to the slope categories. By going to symbology, we can go to categories and we can choose the grid code here and add all values. And to make the symbol matching with the category, we just flip symbol and keep the lowest value of slope at green color and highest value at the red color. You can see that the map is composed of small polygons of each slope category, and we need to dissolve all these small polygons so that we can easily calculate the area that contains in each slope categories. After the dissolve tool is completed, we can go to the attribute table and calculate the area in each slope category by going to add field, and let's type area and choose float here and OK, and let's calculate geometry and area in hectares, and the area is calculated. And you can see that the area in each category is calculated in the area column. And finally, in the last step, we need to go to properties and we should symbolize the map from here according to slope category, and the map will be ready to export. Let's add all values and choose the matching color by flipping the symbol so that lower slope has green color and higher slope has red color. And let's label the categories accordingly: 0 to 19, 19 to 30, 30 to 45 and above 45, and map is ready to export.